Question 5. We've had two short questions which are on the discrete maths side of the exam, the discrete maths strand. There was a probability question, question 2, I think, which was relatively easy. And then this statistics question, which is relatively hard. So it starts off, I would suggest, not too bad. The weights of stones in a bag are sold in the garden centre and distributed with a mean weight of 48.6 grams and a standard deviation of 8.5 grams. A random sample of 50 stones is chosen. Find correct to 4 decimal places the probability that the mean weight of the sample will be less than 49 grams. Okay, as soon as we see probability in a statistics type question, we're thinking z-score. So when we're thinking z-score, then we can go through this. We're talking about the weights of the stones. They have an average or a mean weight. So mu is 48.6. They have a standard deviation sigma of 8.5 grams. A random sample of 50 stones is chosen. So that's the 50 is in the sample size. Find the probability that the mean weight of the sample will be less than 49. So that's your X bar. So we'd fill all those in. We'd make sure we know we've identified each one correctly. We say Z is equal to X bar minus mu over sigma over root n. So we fill them all in and we get this value Z is equal to 0.3328. So what is that? What does that mean? Well, what it means is, in this case, that you're saying, I guess, the probability that your sample mean, the sample weight of the 50 stones will be less than 49 grams, is the same as the probability of a z-score less than 0.3328. Why do we do this? Why do we get this z-score? Because it corresponds to the standard normal distribution curve, and we can calculate the probability that a z-score would be less than 0.33. Well, we can calculate that by saying the following. Well, here's 0.33 just to the right of the mean. So 0.33. And what we're saying here is we can calculate the probability of a z-score being to the left of that, less than it, by looking up 0.33 here, and I get 0.6293. That would correspond with a percentage of 62.93%. So I can say that the probability of a z-score less than 0.3328 is the same probability as having a sample mean less than 49 grams. And in each case, it'll be 62.93 or 0.6293. 10 marks. Hopefully that was okay for students. Here's where it gets a bit trickier. Find the interval which this 95% of sample means lie, okay, given that the mean weight, mu, is 48.6, the standard deviation is 8.5, the sample size is n. But in this case, we're saying, okay, find the interval within which the 95% of such sample means. So the sample means are the X bars. What is the intervals of those X bars that would contain 95% of all values? As I often say, if you don't know what to do, do what you know. Confidence interval, for a population mean. Like, how do I know it's population mean? Well, number one, we're dealing with we have standard deviation here. This is the only one of the confidence intervals that has standard deviation. The X bars are sample means. That's what we're looking for. We're dealing with mu, which is my 48.6. Okay. What happens next? Well, I fill in what I know. Next, let me just fill in a little bit here. X bar is what I'm looking for. Minus 1.96 times sigma, which is 8.5 over root 50. So this guy here is the standard error of the mean. And I'm multiplying it by the 1.96 because that corresponds with the 95% confidence interval. Less than mu, less than x bar. Sorry, and I know what mu is, don't I? Well, I know what mu is. Yep, mu is my 48. This is mu. It's by 48.6. So let me just write that in. 48.6 is going to be in there for mu. Is less than x bar plus 1.96 times sigma over root n. Okay. So what am I going to say? Well, I can then, if I to find my two different values of x bar, I'm basically going to be adding the 1.96. So I'm going to be adding this to the 48.6, and over here I'm going to be subtracting it from the 48.6, and that would isolate the x bar in both cases. So let's just look at another way. We can say the following: the 95% confidence interval is the mu, which is the 48.6 plus or minus 1.96 times 8.5 over root 50 is 48.6 plus or minus 2.356. And so here we have it. We're saying that the 95% confidence interval that would contain 95% of all of the sample means would be between 46.2 grams and 51.0 grams. Okay. Now, the width of this interval is twice this number here. Okay. So the sigma over root n is the standard error of the mean. I'm multiplied by 1.96 because that corresponds with the 95% confidence interval. If I multiply this by 2, I would get 4.712, isn't that right? 4.712. That would be the width of this interval. Now it's rounded here, so you actually end up with 4.8. You might say, how are you rounded from 4.712 up to 8? But it's actually both sides got rounded individually, so the width ended up getting can actually exaggerated a little bit. But that's my width, and the width of the interval is twice this number here, 1.96 times the standard error of the mean. Okay, that's going to be important for this next part. How large would a sample need to be in order that the central 95% of the sample means would lie in an interval of a width at most 4 grams? So here it was 4.712 grams. We want it to be 4 grams. So in this case, it's going to be, this number here is going to be 2 because that's the number that's going to get doubled. We're going to be taking the plus of it and the minus of it. So again, this is my standard error of the mean. I multiplied by 1.96 to correspond with the 95% of all sample means. First thing here, I'm going to square both sides. That will get rid of the square root of n. I'll obviously just have n. So I'm going to have 1.96 squared. And I'm going to be multiplying that by my 8.5 squared. And that's going to give me 277. So I have 277.5556 over n squared is equal to 4. And then I can isolate my n. Yeah, it's not n squared, it's just n. Because obviously the square root of n at start, so it's just n. So I can isolate n by multiplying both sides by n. So they cancel down here and then dividing across by the 4, and I get this answer here. And when I get my final answer, I get n is equal to 69.3889. Now, what is that again? That is the number of stones. I'm going to reread my question. How large would a sample need to be in order that the central 95% of means would lie in the interval of at most 4 grams? So the interval would be at most 4 grams. So therefore, when I'm looking at this number 69.3889, I need to round that up. So I'll be rounding up to 70. And that would mean that if there are 70 stones, the actual width would be just slightly less than the 4 grams, the total width of the interval. And if you calculate that interval for yourself, you will see that that is correct. It'll just be slightly less than 4 grams if you use a sample size of 70 stones. So you might need to think about that one a few times before you're totally confident with it. But we need to have a couple of curveballs in there, and that was one. Okay, so let's move on. And we're moving on to a geometry question, which people might have planned of avoiding, but maybe no. They might think again.